Hi guys, today I'm going to show you how to use rapid GPU accelerated data science method. Basically what I'm going to show you here is use pandas command in a GPU. This is actually a 3-4 years old method, but not widely used due to various reasons. People are not aware of it, so I was thought of give a background of it and create a video. So the idea is to implement this in Google Cloud VM, uh, and process this data file, which is around 2 GB in one file, and um, and show that how fast it. If I go through basic informations here, you can see that how the performance are in the website they have given, and it's truly fast, guys. You can read about 1 billion rows within a couple of seconds, about 1.4 seconds, so which is really fast, and grouping, value count, and everything. This is really valuable when you are doing data science projects on a large data set, and you can save so much of time when you are using with your already available GPU. So let's start creating a Google VM instance. So here I'm gonna select the, normally you need to select area where GPU is available, so I'm going to select one of T4, and then I'm just going to give a normal one, and then apart from that I normally actually use this one. And here you need to do a bit of a change. Make sure you select deep learning ML, and then also you need to make sure you version 11, not 10, because 10 has a Python 3.7, 3.8, but you need at least 3.9 or a 3.10. So that's better to easy to install. So rather than going on with this version and updating your Python, it's better to go with this, and it saves your time. So let's select this one. Yes, TensorFlow we don't need actually, so I'm gonna go with the 50 GB. That should be fine. Select, and I'm gonna give a full access, and then that's it, guys. I'm going with the default setting. So let's create the instance. Normally I use a command prompt, guys. I have a backup of everything. So let's it will take about a couple of seconds. Let's okay, our VM is going to be available very soon. Meantime, I have already uploaded my file to I have already downloaded this New York Kilo taxi data sets and uploaded to a bucket, so that I can transfer it to my VM directly. So instance available, so I'm gonna SSH into it. Okay guys, we got connected. Let's update our, I'm gonna pass forward this area, guys. It's just getting updated. Okay guys, our NVIDIA drive is installed. It might take a couple of minutes just to get everything. So let's check whether our NVIDIA SMI was the CUDA versions and everything. That's fine. And then we need to check our Python versions as well to be sure. So we have 3.11, so that should be fine, guys. So now I'm gonna take you through other stuff. This is where don't worry guys, I'm gonna share you all the installation guideline and everything in my GitHub, in the description area, and GitHub, all the file and everything, so you can So this is the installations documentation for rapid cuDF. So here you can select the versions CUDA or Conda or PIP, and then the CUBA versions, and then CUDA versions, and then CUDA DF, whatever, what's the other, like machine learning model, QML, and other stuff you want. I'm going to select only this one so that I can save time, and then I'm going to select PIP installation, and then CUDA version for my one, and that's it, guys. So everything stable, that's fine. PIP versions, that's all the command I have copied. So now I'm going to do installation. So this is very simple, guys. We just have to paste this here. It will do all the trick for us. I'm going to pass forward here as well, guys. Okay, guys, our installation successfully completed. You can see that here. Now I'm going to do I'm going to connect my VM to a Visual Studio. So what I'm going to do, I have already kind of a setup here. I'm going to go to the remote Explorer, and then go to my SSH configurations, and then what I'm going to do, I'm going to go to my VM, take the external IP, and then I just going to replace this too, so that I can work with the Jupyter notebook here. Let me know, guys, if you wanted to like set it up this the similar way, that if you wanted to work with Google VM using VS Code. It's basically very simple, guys. We just have to go to your config file in SSH link where you are config file, and then the username, and then the host name, basically that's the public IP address. This can be anything. It depends on actually the Ubuntu or root from AWS and things like that. And then here another thing, important thing is that you need to set it up your SSH key. So when you're creating a new any instance, make sure that you automatically add your SSH key to the log. Let me show you guys. So add the SSH key to, let me close this one so that I can clearly show that configuration, deploy configuration, change. So allow access, and then public access, and then go to advanced option, and then networking, that's fine. This security, this is security section, SSH key. So you need to, by default you need SSH key or generate automatically, but you can have add your own SSH key here. Then the SSH key is in here, one of this path. You can find any lot of video on about SSH key, how to copy that and insert it to a copy that and then insert it here. That's the only thing you have to do, guys. That's very simple. And then just replace here, and then you just have to save it and then close it, and then do a simple refresh here, and then just click on connect. It will ask to continue. Yeah, you just got connected to the VM if you open your terminal. That's very simple, guys. So now what I'm going to do is that I'm going to go to open my file structure in my VM, and then it'll take a couple of seconds. I'm going to trust and everything. I'm going to create a folder called project, and then it's fine. So I'm gonna go here, just go inside project, and then add a file. I'm gonna test I'm going to create a Jupyter file, Jupyter notebook, and it's and then I'm not going to connect any of those, and the same time I'm going to add the extension for Jupyter notebook, and then let's install the Copilot as well. Okay guys, so that's it. And then what we need to do is that start running Jupyter notebook in our terminal. So you just have to type Jupyter notebook. A notebook instance will start. So you just copy this to, and then go here, another server, existing server. I'm gonna give a local server connect. So now you are connected to the environment in here. So basically what you have to do, go here and go here, existing Jupyter notebook, and then copy your path here. Go here and then copy and enter, then you are connected. Basically let's check whether pandas as pd, just run and see, just the panda is available. Yes, panda is available. Now I'm gonna import cuDF as well. You can see this will take a bit of a time to live to get import. That's everything is fine. Now what we have to do is we need to get our large file to the Google Cloud. So what I'm going to do, I'm going to create another terminal, ls, and then I'm going to cd to the project, and then I'm going to use Google Cloud command to copy the file. gsutil cp, and then I'm gonna copy the path of my data sets and then paste it, and then copy the name again and then paste it. So that's it. It will take a bit of time to copy paste the file because we are copying 1.8 GB file, guys. Don't worry if you are buckets in the multi-region, there won't be any costs because if it's a VM in the same region. So for me it's a US, and transfer between US in the same region is free of charge. You won't be spending any money on this data transfer. So it's gonna take a bit of a time, guys. Okay, our file is copied. Let's check. File is available, so we need to unzip. So we are going to unzip the file. It's going to take a bit of time again, guys, to unzip the file. You can already see this start getting unzipped this file. The one file is already unzipped, so I'm not going to wait till everything get unzipped. So here, guys, now we can start using the cuDF. It's a very simple method, nothing major you have to do. Let's get the NVIDIA SMI also to see our memory usage. So if you look at already just very small amount, nothing is mainly happening here, no processors or nothing running. So now I'm going to read this file. So what I'm going to do is that it's normal df equal cuDF dot read CSC. So that's the normal command that we are using. Normal earlier in pandas we use pd read ds, so here just the same thing. So what I'm going to do is I'm going to copy the file names from here, cd project ls. So take the one of this file. Okay guys, I'm gonna put it here and then run it. Look at the time it's gonna take. It's only 2.7 seconds to read how many rows. So 1.2 billion rows, guys. How fast is that compared to pandas? Let's check the pandas as well. df df pandas equal pd.read. It's still going, guys. It's still going. It's still going. It's gonna take a long time. Meantime this is reading. I'm just gonna go I'm gonna stop, guys, because it's going to go ever for sure, because it's a large file. 2.7 versus is still running. It's still going. You can see that how inefficient is the Panda reading that large file is. So you can do all sort of command here. Let's say I wanted to group by something. Okay, before go that let me show you now what has happened to our NVIDIA SM. So can you see that's already load 2 GB start using. So if I load another data sets, let's say df 2016 or something, there's another file for 2016 here. So what I'm gonna do is that copy one of those file, and then if I run this one, earlier the SM let's check the SMI again. We are using, guys, 2 GBs. Now I'm gonna read again another file. So I'm gonna take 2. Okay, sorry guys, I'm reading the normal way. So I'm gonna put cuDF and then read it. Okay, 1.4 second, guys. Now let's see how much is memory is using. Can you see, guys, that's already start reading a large. So if you want to remove this any data frame, you just need to remove from the memory. You can df put it that and then enter. It will remove from your memory. So if I go here and then, can you guess, we got back our that's from 4 GB to 2 GB back again. So now if I run anything on here, it won't be there in our memory because we already remove it. So let's do some other tasks as well. Group by, so let's say a column. Let's look at the data sets. We didn't look at it even. So heads, so let's look at 2 columns. Let's me take this out and make it smaller so we can see the columns, and make it bigger as well. So let's group by rate card ID. Count show. So let's see. So I'm getting error, guys. So count. So rate guide at count. Can you see, guys? It's very fast. Only 1 second to go through all the data. That's the main thing, guys. Here I'm going to show the share the where you can access this one. And before I go, I'll make sure to give another way to access the same thing. If you go to this website, I'm going to share in the description section. There is a different way of you can run it. You can use the Amazon SageMaker Lab. This is also free of charge, and you can use the collab. If you click one of these link, you can open your collab library and run free of charge. So this is something that I heavily use my day-to-day life projects, because I have already when I work with the Google Cloud, when I work with a large file, it's easy to use that way and save time, because it's the same set of Fanda commands. You don't need to create anything else like Spark cluster or anything like that to use this highly efficient method of working with large set of data. That's all guys today. Thank you for watching. See you in next time. Bye.